So, hello everyone. Today we are going to discuss about chapter 1 of your class 9th NCERT, Orienting Yourself, the use of coordinates. So, first what we are going to discuss, we are going to discuss the brief history of coordinate system. First understand what is the meaning of coordinate system. So, coordinate system is an structure framework that enable us to use numbers to describe the physical location of any point or object in the space. What is the meaning? So, meaning of any coordinate system, the aim of any coordinate system, making any coordinate system, what is the aim of any coordinate system is to locate the position of any point in the space. That is the main aim of developing any coordinate system. So it is a structured framework. What is the meaning of a structured framework? So this is a structure, when you are developing any coordinate system, you make some structure. Like for the Cartesian coordinate system, this is 2D Cartesian coordinate system. For this 2D Cartesian coordinate system, we have developed a structure like there are several parallel lines, vertical and horizontal. These lines crossing each other perpendicular at 90 degree. So this is the structure what we develop in the Cartesian coordinate system, that is a 2D two-dimensional Cartesian coordinate system. So this is the structure framework. So we have another type of coordinate system, like we have many coordinate system, three-dimensional coordinate system. We have a polar coordinate system, which is not in your syllabus, spherical, polar. Different type of coordinate systems are used in practice for giving location of any point precisely, which is not in your syllabus. We only in this chapter discuss about 2D Cartesian coordinate system, which is in your syllabus, and also discuss some application of 2D coordinate system, like finding the distance of 2 points and how to locate any particular point in 2D coordinate system. These things we will discuss in this chapter. But first, we is this video only discuss about what was the historical background, how we developed many coordinate system, and what was the role of many mathematicians and their new theorem, their new siddhants, through which by the use of those siddhants and theorems we develop certain coordinate system. So in this brief history chapter, we only discuss about the evolutions, how we evolved to modern coordinate systems, and what was the role of many scientists and how their ideas, innovations used for developing any particular type of coordinate system. Getting what is the meaning of coordinate system? So coordinate system is a structure framework. Like today coordinate system, we have grid patterns, grid structure, and we use particular numbers for describing the exact physical location of any particular point or object. So first understand how we have started thinking grid based system for giving position of any particular point, for describing the location of any particular point. So it happens first grid system thousands of years ago in the Sindhu Saraswati civilization. Open your NCERT and read this chapter with the NCERT. These lines are taken from the NCERT. Sindhu Saraswati civilization, which is also known as Indus Valley civilization. Maybe in your other textbook you read the name Indus Valley civilization. That is the Sindhu Saraswati civilization. This Sindhu is a river, Saraswati is a river. Both are the river. This civilization flourished in between these two rivers. That's why it is known as the Sindhu Saraswati civilization. So here, what we get in the Sindhu Saraswati civilization, if you look at the road, so each roads are in particular two direction. One is the north south direction and second one is the east west direction, and these roads are crossing each other at the 90-degree, means making grid patterns, and their distance between two roads are 10 meters. These are same for all the roads. So grid based thinking comes in the Sindhu Saraswati civilization for the first time. So how people use these roads for describing the location of any, let's say you are a merchant here, you have a reference point here, and some shop is here. So for reaching this shop, what you need to do, you need to follow this road for south direction for 1 unit, and then east direction for another 1 unit, through which you will be easily reach to this particular shop, or you can easily locate any particular shop or house or any warehouse just by describing the number of unit of each road. You need to cross in the east direction for 10 units, 5 units, and west direction for 10 units for 5 units. So grid based thinking for describing the location of any particular point was come first in the Sindhu Saraswati civilization thousands of years ago. That is the first development of grid based thinking. And you know, in your class 8 you also read Buddha Pythagoras theorem. So Buddha, they what he did is that he used this north south and east west line as the perpendicular lines for making his geometric constructions. You read in your 8th class, like Buddha and Pythagoras theorem. This is a uh, right angle triangle, and the square of this length hypotenuse, which is equal to the square of this base and this height. That is the construction given by the Bodhayan, that the area of the square formed by the hypotenuse is equal to the area of square formed by the base and the height. So this is the another major event which happened in the history in the reference to the making of any coordinate system. So these are the two main events, like grid based thinking. The first one is Sindhu Saraswati civilization, and second one is the development of Bodha and Pythagoras theorem. Now comes some another aspects of development. So putting the coordinates of any particular point on the Earth's surface become very important for the navigation. So for locating any particular point and for traveling from one point to another point, putting the coordinates of those points on the Earth's surface become very important. So Ujjaini was described in the ancient world at least as early 4th century before Common Era in the early Siddhant as the point marking the central longitude meridian from which all other locations were mentioned. Try to understand this. So for describing any location on the earth, we have another coordinate system, that is the latitude and longitude. You will read, maybe it is if it is in your syllabus of geography. So what is the latitude and longitude? Understand in brief that let's say it's your earth. So you know, this is the north pole and south pole, and this is the equator. So what we do for the measurement of any particular, for the coordinates of any particular point on that, let's say any point is here, we measure its two angular distances. One angular distance from the equator, that is known as the latitude. We mark this equator as the 0 degree latitude, and all the distances above to this equator, let's say any point is here. So this is on a particular meridian, and it is making some angle from the equator, that is, let's say theta 1. So this theta 1 would be your latitude. So how many latitude are here? From 0 degree to 90 degree north, and from 0 degree to 90 degree south. These are the latitudes of any point. So for making another reference plane, there are a longitude if you here. So you know how to measure latitude. Latitude is nothing but the angular distance from equatorial plane, and longitude for measurement of any longitude of any point. We have divided this earth in many great circles. crossing from running from north pole to the south pole. Okay, so what we take one great circle as their reference point. For the reference point of the earth longitude, we had taken the Greenwich meridian, and we measure all the longitudinal position from this grid in the eastward or the westward. That you will read in your geography class if it is in your syllabus. So what is latitude and longitude? There is nothing but the angular distance. One is from the equatorial plane, that is your latitude, and second one is from a conventionally mentioned reference point, that is reference meridian, that is the Greenwich, from where we measure the longitude of any particular point. So by the measurement of these two angular distance, we can describe any particular point on the earth surface. Okay, so in Ujjaini was the place. Right now in today's time we are taking reference point Greenwich line. That time in ancient time Ujjaini reference was meridian was taken as the reference point, and this Ujjaini is Madhya Pradesh, in the Madhya Pradesh India, in the state of Madhya Pradesh of India. So in the 4th century before Common Era, this place was taken as the 0 degree longitude meridian, central longitude meridian, from which other meridians were what from this reference are measured in the eastward direction or the westward direction. So now another term, Ptolemy described the latitude and longitude of thousands of locations. He was a mathematician. He came to India. He also described many latitude and longitude of many places in the ancient time. Now come to the Aryabhat major development. What he did replace the card with the signs, making much easier to calculate the coordinates of a star or a city. What is the circle? And there is 2 points on the circle. If you join these 2 points, this line segment is chord, is known as the chord. So for the measurement of chord, let's say this is the center of the circle. What he did, he replaced this chord with the sign. What is the sign? You know, it is the ratio of two length of a triangle. So if you draw a line from center to the this chord, you will notice this is a right angle triangle. So by the use of sine theta, this let's say this angle is theta, you have a ratio of two length of this the triangle. So if you know only one length and you know the ratio by measuring the angle, because Aryabhat gives the ratio of many angles like sine 30 degree, sine 45 degree, if you know. So by measuring the one particular length, you can calculate the another one without complicated calculation. So that is what the Aryabhat, that he replaced the chord with the signs and easier make for making the for calculating the coordinates of any star or any city. He mapped the sky using the celestial coordinate system, measuring coordinate distance from the ecliptic. What is the ecliptic? The path of the sun. What is the path of the sun? If you look into the sky, you will notice that sun rises in east and it goes to the west on a daily basis. But sun also moving in a particular part. Sun is not moving. Our earth is rotating around the sun. Let's say this is the sun. So this is our earth. It is rotating, revolving around the sun. But since we are on the earth, so it appears that sun is revolving around, sun is moving in any particular path, and the path with which sun is following, that path is known as the ecliptic. But actually sun is not following that path. It is because of the movement of the earth, because of the revolution of the earth, it appears that sun is following any particular path in the sky, and that path is known as the ecliptic. So now don't go into a lot of deep measuring how. If you want to know about the celestial coordinate system, it is another type of coordinate system. So as we had seen here, in the latitude and longitude, what we do in the celestial coordinate system, we observe a halo sphere outside the Earth's surface, and when we assume a halo sphere outside the Earth's surface first thing, and then we extend this Earth equatorial plane. This is the equatorial plane of the Earth, as we had seen the latitude and longitude. We expand this equatorial plane to this halo sphere. So one reference point become this equatorial plane, and second reference point we have to take, and for that things are slightly complicated for taking the second reference point. It is, the time when sun ecliptic crosses this Earth equatorial plane. The time it crosses here, this is in the month of March and April, that meridian is taken as the second reference point in the case of uh, you know in the case of celestial coordinate system. So we do not go into that depth how we develop, how we measure the position of any star by the use of celestial coordinate system, or this coordinate system. That is not in your syllabus, and it is uh, in your higher classes you will read how coordinates are mentioned in the celestial coordinate system. Now, come to the Brahmagupta work. What is the meaning of this C? If you look in your book, the C refers to circa, which means approximate value. Means is its year 628 common era, that is the approximate value. So what is the common era and before common era? You notice many times when you are reading. Understand this thing. This thing, timeline, let's say, and this is the year which mark the birth of, Jesus Christ. Okay, Jesus Christ. This marked the birth of the Jesus Christ on the timeline. So all the years which is forward, which were forward to this birth line, is known as the common era. So 628 common era means after the birth of Jesus Christ, it has been 628 year, and before common era is backward direction. You need to move before the birth of the Jesus Christ. That is known as before common era. So this is the timeline for the common era and the before common era. So what Brahmagupta formalize, he formalized the notion of zero, and also give the negative numbers as the algebraic entities. When we are discussing about the 2D coordinate system, you know, we have taken a point as the origin zero. So without zero, how can we take this origin? So it was a major event which happened in the development of coordinate system. Again, when we are thinking about this coordinate system, we have negative numbers here in the left of the x-axis. We have again negative numbers down to the y-axis. So without negative numbers, without formulas of zero, it would not be possible to tell a 2D Cartesian coordinate system. So it was also an important work of the development of the Cartesian coordinate. I hope you are getting. Now come to the where we are here. Without him, four coordinate system would not be possible. Read this line in your NCERT book. Brahmagupta were translated into Arabic as the Sindhi, and Ujjaini meridian in the Arab geography under the name of Arin. You know what is the Ujjaini meridian? We had taken this Ujjain as the reference point for calculating the other coordinates of other points in the on the globe. Now this also served as zero longitude reference to early Arabic maps. So early Arabic map, if you look, this Ujjain served there also as a 0 degree meridian. Now come to the another mathematician, Arab scholar Al-Biruni traveled to India, studied Siddhant. Siddhant means rules, like Pythagoras theorem was one of the rules. So he used Indian trigonometry method to calculate the coordinates of various cities across the Asia. So he used the Siddhants and trigonometry method to calculate the coordinates of various cities across the Asia. Al-Biruni later perfected the astrolabe, a handheld device that allows sailors to find their. He also perfected this device, which were used by the sailor for what? For locating their coordinate by looking at the stars. So sailors means travelers who are traveling in the seas, known as sailors. For their coordinates, they use these devices, and this scholar, he perfected this device. Now come another important event in the history of development of coordinate system. Omar Khayyam, who had become an expert in Indian decimal system and algebraic formulas. Algebra means, in the branch of mathematics where we replace number by the use of symbols like uh, x, y, z. We use these symbols to the numbers to the equation in the algebra. In the algebra chapter, we understand these things in better manner. For us to save algebraic drawing using geometric interpretation in terms of coordinates in the term. We have developed 2D coordinate system, and in the 2D coordinate system, what we learned that we can locate any particular point by the use of two numbers. That is the 2D coordinate system. So if you have any algebraic equation, let's say y barabar mx plus c. So by use of these coordinates, you can draw this algebraic equation on the 2D Cartesian plane. And if you have any figure, any geometrical shape in the 2D Cartesian plane, by the use of these coordinates, you can also draw the algebraic equation for that particular geometric shape. Getting what is the meaning? Let's say meaning is that, let's say this is, we have the algebraic equation. By the use of coordinates, we can draw this equation on the 2D coordinate system. And if we have any particular geometrical shape on a 2D coordinate system, by the use of these coordinates, we can draw the algebraic equation for these coordinates for this geometric shape. That is the meaning of the thing, that we can use algebraic equation from drawing particular geometric shape, and we can also use geometric shape for drawing particular algebraic equation with the help of 2D Cartesian coordinate plane. So these concepts eventually reached Europe in the 12th century. The faint leap in occurred when following related work, the Fermat and Descartes. Okay, so 2D Cartesian system is known as a Cartesian system because of the name of this mathematician René Descartes. This Cartesian word comes from his name Descartes. So he used Fermat's work, and shows he formalized the fact that in the 2D Cartesian plane, what we can do, we can locate any particular point very precisely just by measuring its distance from y-axis and x-axis. That's why this system is known as the Cartesian coordinate system. So this is the distance x, this is the distance y. Okay. So that is in two-dimensional plane. The could define simply two number representing the point distance from two perpendicular axes. So these are the two perpendicular axes. By the use of these two axes, we can precisely define the any particular point in the 2D Cartesian plane. Points and more complex geometries that could be then described precisely using algebra and equation, and thus bringing the areas of geometry and algebra come even together. But what we have discussed is something written here, like by the use of algebraic equation, we can represent the same in the geometrical shape by the use of coordinate system, and the vice versa. We can represent any coordinate system with geometric shape to the algebraic equation by the use of this coordinate system. Also, the last thing of the brief history, also using coordinates enable us to visualize algebraic equation as geometric shape and vice versa. The same thing is we have discussed. By the use of algebraic equation, we can make geometrical shape, and by the use of geometrical shape, we can develop the algebraic equation. So these are the brief history. We have seen some mathematician, their work, like Brahmagupta, like Cartesian, like Ptolemy, and some important thing, some other type of coordinate system like latitude and longitude. In the latitude and longitude coordinate system, we measure the angular distance of any particular point from two plane. One is the equatorial plane, and second one is the reference plane. That is, for the Earth case, we have Greenwich reference point as the reference plane. This is the Greenwich reference. And in the celestial coordinate system, we extend that particular system to the by assuming an halo sphere in outside the Earth, and one reference point we take is the equatorial plane. We just expand that equator to the that halo particular sphere, and second reference point we take by the time when sun ecliptic crosses the sun ecliptic crosses the Earth's equatorial, then at that particular point we take a reference point and we measure the coordinates of celestial object like star and sun. So that is what is brief history, which is in your class 9 NCERT. And then later lecture we understand 2D Cartesian plane and try to solve some question related to the 2D, related to the 2D Cartesian plane. So thank you.